Okay, welcome to the Notes on Biodiversity. We're going to talk about all of the different living things that are out there on the planet and why they're so important. So make sure you write down your objective to relate biodiversity to biological classification, which we'll be talking about a little bit in class, and identify the criteria used for classifying organisms. All right, so biodiversity simply means the variety of organisms at all levels of classification. And we've seen biodiversity increase over time in terms of evolutionary time, okay, since the beginning of the planet, basically since the beginning of life. Because we're talking biodiversity, we're of course talking about living things. It can definitely be argued that recently biodiversity is actually going down, and you guys might be able to think of some reasons for that. So you see here a picture of the tropical rainforest. This is probably one of the areas on the planet, terrestrially on land, that has the most biodiversity in terms of different forms of plants, animals, insects, fungi, you name it, the rainforest has it in bushels. Oceans have huge biodiversity, especially coral reef areas. But one of the places that we definitely think of as having a lot of biodiversity would be a rainforest. Now, this whole idea of biodiversity and classification of organisms came about a long time ago. Aristotle was one of the first people to start really trying to organize different life forms, and he basically divided everything into just two groups, plants and animals, because he didn't really have a lot to work with. You see that he was alive, before Christ, 380 years before Christ. So this was a long time ago. This is, almost 3,000 years ago. But what he tried to do was develop a key to classify organisms by type, and we're actually going to be working with that in class. And then a long while after him, Linnaeus came around, and Carolinus Linnaeus was a Swedish biologist who actually started looking at form and structure. So comparing organisms that were similar to each other even more closely to get an even better system of classification. And he created this hierarchy and something called binomial nomenclature. And we'll talk a little bit about what that means later on. It's important to just kind of understand where this is coming from. You guys don't need to write this stuff down. I just want to give you a little bit of brief sort of background on where the scientific history of this is. So here's kind of what Aristotle developed. Like I said, it was very, very simple. So he said there was this group of animals, okay, and animals could be divided by having red blood or not having red blood. Those that had red blood were mammals, lizards, birds, and fish. Those that had no red blood either had hard bodies or soft bodies. If they had a hard body, they were an insect. If they had a soft body, then they either had a shell or no shell. If they had a shell, they were shellfish. If they had no shell, they were jellyfish. And this is about as complicated as his key got. We'll be seeing some examples of this that are obviously much more complicated in class. You don't have to know this, but we call this a dichotomous key, and dik means two, and temnian means to cut, so to cut into two. We're always cutting them into two groups. So we talk a little bit about the levels of classification, and each level is a group of organisms with similar traits, starting with all of life. And then you take all of life and you divide those into 3 domains, and then those domains get divided into kingdoms, and each kingdom gets divided into phyla, and each phylum gets divided into classes, and so on. Whoops. All the way up to species, which is the most specific. Species is specific, and you'll only ever find one organism here at the species. And so I'll show you some examples of that here in a moment. So basically, like I just said, how it works. Many different kingdoms in a domain, many different phylums in a kingdom, classes, until you get to one. So basically, each of these groups keeps getting progressively smaller and smaller and smaller and more closely related to each other until you get to this one individual species. Another important key term for you guys to know is this term taxonomy. It's the science of naming living things, and not like giving your cat a name. We're talking about naming the organisms and using this uniform scientific name. The binomial nomenclature that Linnaeus created back in the 1700s, we still use that today. We're still adding names in that fashion today. And so we'll talk a little bit about that too. It's a 2-word Latin naming system. And the reason that we use Latin is because it's the same and it's never going to change. And we can all, as scientists, understand a certain portion of Latin to help us better understand science. And anybody anywhere in the world, Latin's going to be the same for them. And so it's not like we, as Americans, are just going to name everything in English names and hope everybody just learns the English. You know, Linnaeus used Latin, and so we continue using that today. Scientific names are written in a very specific way. So you capitalize the first name, which is the genus, and then it should be underlined or italicized if you type it. So here's an example, Homo sapiens. That is the scientific name for humans. This is the genus Homo and the species Sapiens. We are the only species left from this genus of Homo. All of the others are now extinct. And we'll get a little bit more work with this, like I said, later on in class. So that's it for this set of notes, and I will see you guys in class.